Okay, so a system of inequalities is two inequalities, or two linear inequalities, with two variables, or containing two variables. All right, and then the second asterisk there at the top, that's what I already talked about. You're going to do the same thing we did on Tuesday, except we're going to be looking for the double shaded region now. So on the first two problems, they're kind of like what you had yesterday, like on 20 and 21, and I think it was 10 and 11, or I should say on Tuesday, I mean. You just have to plug in the point and decide whether it makes both inequalities true. All right, so if it makes both inequalities true, then it's a solution. If it makes one of them true and one of them false, or if it makes both of them false, then it's not a solution. So let's try this first one. So all we have to do is we're just gonna plug in this for x and this for y into both of these inequalities. So in the top one, we're going to plug in -3 for y. So that's going to say -3 is less than or equal to -3 times the x, which is -1, and then plus 1. And let's just plug them both in at the same time here. So then in the bottom one, I'm just going to plug x and y in again. So the bottom one, I'm going to plug the -3 in for the y again. And that is going to be less than 2 times the x, which is -1, and then plus 2. So let's work both of these out. So the top one is going to say -3 is less than or equal to, well, on the right-hand side of that one, you have -3 times -1, that's 3. 3 plus 1 is 4. Well, that's definitely true. -3 is less than or equal to 4. Again, just think on the number line. The greater numbers are further to the right on the number line. And then the second one is going to be -3 is less than, well, on that one we've got 2 times -1, that's -2. -2 plus 2 is 0. So that one's also true. -3 is less than 0. So since that point, that ordered pair, x comma y right here, since that makes both equations true at the same, or I should say both inequalities true at the same time, then yes, it's a solution. Now all you guys have to write is just yes, but I'll write yes, it's a solution. All right. And I think we'll skip number 2 just to save some time. You do the same thing on number 2. You plug in the x and y into both inequalities. If it makes them both true, then it's a solution. If one of them's false or if they're both false, then it's not a solution. Hey Josh, put a normal background on your screen, all right? Again, I'm going to have Zaborowski in here next week, and you're definitely not going to be able to do that, all right? I'm going to call you out. Same thing, Anthony, you're going to need to have your face on the screen. All right, so let's go to number 3. That should give me enough room, I think. All right, so number 3. So I'm going to review the steps from Tuesday, since we weren't here yesterday. So the first thing I told you guys to do on these linear inequalities is change the inequality signs to equal signs. And that was to help you locate your line. So the top equation, or I should say the top inequality, this one is going to become y equals 3. And the bottom one is going to become y equals negative 1 over 1x plus 3. Okay? And again, we changed those to equal signs just to help us locate the line. But then we got to remember that if it has the equal to bar in the inequality, it's a solid line. But then in the bottom equation, there's not an equal to bar, so then it's a dotted or dashed line. So I want to make a note of that also. So this top one is a solid, right? And the bottom one is dotted. All right, so let's see if we can graph these. So the top line there is y equals 3. Well, that, if you guys remember, if it's a y equals just a number, that's a horizontal line at y equals 3. But we got, and that one is going to be solid. Excuse me. So let's do that one in, I don't know, we'll do that one in red. So it's a solid line, horizontal through y equals 3. Well, then we need to test a point. So I told you guys on Tuesday to test 0, 0. So we're going to test this point, and we're going to plug it into the original inequality. So we're going to test 0, 0 into this original inequality. Well, that means we're just going to plug the 0 in for y. There's no place to plug an x into that one, right? So if we plug that in, we're just going to put 0 in for y, and then that's got to be less than or equal to 3. Well, that's true. So since that's true, and we pick the point 0, 0, then we're going to shade that side of the line where 0, 0 is. So we're going to shade this one like this. Okay? Now we have to do the bottom equation, and then we're going to, or I should keep saying equation, we're going to do the bottom inequality. That one's going to be dotted, and then the solution is going to be all the points in the double shaded region. So that bottom line is going to be dotted. We can see that the y-intercept is 3, and the slope is down 1, right 1. And let's do that one in green because we're coming up on the holidays here. So we got a y-intercept of 3, so that's right here. And then we have a slope of down 1, right 1. So down 1, right 1. All right, but then we got to remember that second line there is dotted. So that is going to look something like that. And again, we're going to test 0, 0. So we're testing this point right here. And so we'll test 0, 0 in the bottom inequality. Well, if we do that, then that second inequality is going to say 0 is greater than the negative of 0 plus 3. That's going to give me 0. Well, the negative of 0 is 0, so 0 plus 3 is 3. So it's going to say 0 is greater than 3. And that is not true. So since we picked 0, 0, so since we picked this point and it's not true, we have to shade the other side of the green dotted line. So that is going to look like something like this. So then hopefully you guys can see where the double shaded part is, okay? All the points that are solutions, they are in here, in that region. All right. This part's not shaded at all. That part's only shaded green. Over here, it's only shaded red. So the solution is all the points in this region right here, where it's shaded green and red. I'm just kind of looking to see who's here. Grace and Clavon, you're supposed to have your camera on. All right, so that's your solution, okay? All the points in the double shaded region, that's it. The graph is your solution. Now, you could write down one of the points if you wanted like one particular solution. You could pick a point in that double shaded region. So you could go like, I don't know, what should we pick? Maybe like, I don't know, let me find a point here. How about like right here? That purple point, that's definitely in the double shaded region. That is the point 7, 0. So that would be a sample solution, okay? Because sometimes they ask you to write one down. So that would just be one example of a solution, would be the point 7, 0. That would make both equations true at the same time. Or I said equations again, sorry. That would make the point 7, 0, x equals 7, y equals 0. That would make this top inequality true, and it would make the bottom inequality true. Does that make sense to you guys? Kind of? Again, if you have any questions at any point, just give me a shout out, all right? Just unmute yourself. So let's look at number 4. All right, so there's number 4. So let's try to do these two again. We're going to change the inequalities to equal signs just to help us locate the line. So the top line is going to be, what do we got here? So we have negative 3x plus 2y equals 2. And the bottom line I'll put over here on the right, that would be y equals 4 over 1x plus 3. But then again, we got to remember that the top one here has the equal to bar, so that's got to be a solid line. The bottom one does not have the equal to bar, so then that's going to be a dotted line. So we're going to make a note here. This top one's solid. This bottom one is dotted. Because a lot of times I forget to do that. Well, the second line is in the form y equals mx plus b. That's your slope-intercept form. But the first line here, this is in standard form. And when you're in standard form, I like to use the intercepts to graph those. So I'm going to make this little table for you guys. And I'm going to plug 0 in for x and 0 in for y. So if I plug 0 in for x, I would just cover this up and solve for y. So divide both sides by 2 and you get y equals 1. Oh, let me undo this first, hold on. And then I would plug the 0 in for the y. That would find me the x-intercept. So if I plug 0 in for y, then I would just cover this up. And then I would solve for x. Well, if I divide both sides by negative 3, I'd get x equals negative 2/3. All right? So then let me plot these 2 points. So let's see, this one, let's do the first one, we'll do in blue, I guess. So I got the point 0, 1, that's right here. And then I have the point negative 2/3, 0. Well, that's just 2/3 of a unit to the left. So that would be like right here. And that's good enough. I'm going to graph this line. It's a solid line. So something like that. And then I'm going to test 0, 0. Let's see if I can fit that in here. So if I test 0, 0, I'm going to put that in the original inequality, the top one. That's going to give me negative 3 times 0 plus 2 times 0 is greater than or equal to 2. Well, negative 3 times 0 plus 2 times 0, that's just 0. So I get 0 is greater than or equal to 2, and that is false. So then if I pick 0, 0 right here, and that makes a false statement, then I know that I have to shade the other side. So I'm going to shade above that blue line. So that is going to look like this. Okay? Now I got to do the second line. So the second line over here, my y-intercept is 3, and my slope is up 4, right 1. Let's do that one in, I don't know, I guess green. So my y-intercept is positive 3, so that's right here. And my slope is up 4 over 1. So 1, 2, 3, 4 over 1. All right, now I got to graph that line. So, hold on, my iPad just changed screens on me here. Oh, it just zoomed in is what it did, or zoomed out, I should say. Let me see if I can do this without messing it up. Now I got to remember that bottom line is dotted, right? So it's kind of like that. Again, I'm going to test 0, 0 in that bottom inequality, the second one. So if I do that one, I'm going to plug 0, 0 in right here for x and right here for y. So if I do that, I'm going to get 0 is, well, actually I should write, I'm testing 0, 0. So I'm going to put the 0 in for the y, and that's got to be less than 4 times 0 plus 3. So the left side is 0. That's got to be less than 4 times 0 plus 3. That's 0 plus 3, which is 3. And that is true. 0 is less than 3. So since I picked 0, 0 and it was true, I picked this point and it's true, then I shade the side where I picked the point. So I'm going to shade the right side of that green line. So that's going to look like this. So something like that. So the solutions are the part that is both green and blue at the same time. So hopefully you can see that the solutions are up here. Okay? So what you're really looking at, if you look at this thing, if I drew this for you guys, here, let me do this. You got a graph that looks something like this. You got one line that goes like this. You got another line that goes like that. So then this part in here is not shaded at all. This part over here is only shaded blue. This part is only shaded green. So then your solution points are actually in here. So hopefully that kind of makes sense to you guys. That's the double shaded part, the part that's both green and blue. I know I'm going kind of fast today because this is kind of a long lesson. Again, if you guys need something, just unmute and shout out and stop me, okay? So let's look at these next three, but I'm going to go through these fairly quickly, okay? Again, same stuff we've been doing. So let's look at 5, 6, and 7. Well, first of all, it says these are special graphs. And the reason these are special is because if you look at them, they all have the same slope. So that slope is -2/1. This one's -2/1. This one's 3/1. That one's 3/1. This one is 4/1. That one's 4/1. So these are actually lines that are parallel. If you have the same slope, the lines are going to be parallel. So special graphs, we're going to fill in that blank right there. That's going to say these are parallel lines. So when we did these before, when we did these, when we were solving where, let me zoom in a little bit. When we were solving these before, when these were equal signs, if the lines were parallel, then there was no solution, right? Because we were looking for, when these were equal signs right here, we were looking for the point where the two lines crossed each other. That was the solution. So if the lines were parallel, there was no solution. Ethan, you got to put your camera back on. Oh, there you go. But now that's not the case anymore. These are inequalities, so these are different, okay? These can still have a solution because we're going to have some parallel lines and we're going to be looking for a double shaded region. So let's try these. And again, I'm going to go pretty quick on these. So let's do this first one. So on the first one, we got a y-intercept of -4 and a slope of down 2, right 1. And on the second inequality, we have a y-intercept of 5 with a slope of down 2, right 1. So let's do the top one in red. So I have a y-intercept of -4, which is right here. And then I have a slope of down 2, right 1. So I'm going to quickly sketch this line for you guys. So it looks something like, let me turn my iPad here. Also be aware that this first one, I almost messed this up. This first one right here, that is a solid line. All right, and then we're going to put 0, 0 in here really quickly. I'm not going to write it out, but we're going to put 0 in for y and 0 in for x. If we do that, this top one is going to say 0 is less than or equal to -4. That's false. So since I picked 0, 0, and it was false, I need to shade the other side. So I'm going to shade this side. Okay, well then on the second line, the y-intercept is 5 and the slope is down 2, right 1. So let's do this one in blue. So y-intercept is 5, which is right here. Slope is down 2, right 1. So let me graph that line. So hopefully you can see both lines are parallel. Now I almost messed this up again. On this one, notice it does not have the equal to bar, so we got to do a dotted line. So that's going to look something like this. Again, we're going to test 0, 0 in here really quickly. So test 0, 0. We plug that into the bottom inequality right here. Well, that's going to give us, let's see, 0 is greater than 5. That's false. So since we picked 0, 0 and it was false, we need to shade the other side of the blue line. So we're going to shade this side. Now remember, the solutions on these problems are the double shaded region. So I haven't been asking many questions today, but I've been trying to hurry to get through this for you guys. Where's the double shaded region on that one? Somebody's got to unmute.
There isn't one?
Yeah, there isn't one. So there are no points in a double shaded region, so that means there's no solution. So this one had no solution. So we're going to write no solution here. Oh, I can't spell solution. All right, so that one had no solution. All right, well, let's look at number 6 real fast. Again, I'm going to go pretty quick on these. At least on 6 and 7, or 5, 6, and 7, they're all in slope-intercept form already, so they should be pretty quick to graph. So let's try number 6. Let's do the top one in purple. So we're looking at the top line here. The y-intercept is -2, and the slope is up 3 over 1. So a y-intercept of -2 and a slope of up 3 over 1. All right, so we're going to graph that line. Again, make sure that you note that this one would be dotted. So it would look something like this. Now that one's pretty close to 0, 0, but I think you can see 0, 0 is to the left of it. So I'm still going to test 0, 0. All right. So if I test 0, 0 in the original inequality right here, that's going to put in 0 for x and 0 for y. That's going to say 0 is greater than -2. That is true. So since this point made it true, I got to shade the side where I picked the point. So I'm going to shade to the left. So that's going to look like this. All right, let's do the other one here in green, I guess. So for the other one, my y-intercept is 6 and my slope is up 3 over 1. So I need a y-intercept of 6. That's right here. And then I need a slope of up 3 over 1. And then again, note that that one is also going to be a dotted line. So let's try to do that. So that's going to look something like this. Then I'm going to test 0, 0 again. So I test 0, 0 in the bottom inequality here, and that's going to say 0 is less than 3 times 0 plus 6. Well, that's true, because that's going to say 0 is less than 6. So since 0, 0 made it true, I want to shade the side of the green line where I picked the point. So I'm going to shade to the right of that line. So that's going to look like this. Okay, so hopefully you guys can see the solutions to this problem then are the double shaded part, so the part that's purple and green. And that is the part that's in between the two parallel lines. Do you guys see that? This part over here is only shaded purple. This part is only shaded green. So the solutions are where it's double shaded blue and, not blue, purple and green, right in here. So any point between those two parallel lines would be a solution. Not including the points on the lines because they're dotted lines. All right, let's do number 7. So number 7, let's do the first one in blue. So the top line, the y-intercept is 6 and the slope is up 4 over 1. So we got a y-intercept of 6. And then we need to go up 4 over 1. And then note on this one, these both have the equal to bar, so these are both solid lines. So let me draw that first one. So something like that. All right, then I'm going to pick 0, 0, and I'm going to plug it into the top inequality. So when I plug it into this one, put in 0 for x, 0 for y, that's going to give me 0 is greater than or equal to 6. That's false. So since this point made it false, I have to shade the other side of that line. So that's going to look something like this. All right, let's do the bottom one. So let's do that one in green. Let's do red. So we'll do red. The bottom line there, or the bottom inequality, this one, that one has a y-intercept of -5 and a slope of 4 over 1. So y-intercept of -5 and a slope of up 4 over 1. So you can see those lines are parallel. This is also a solid line. Something like that. And then I kind of missed my line here a little bit, but that's okay. We'll just make the points larger. Okay, and then we're going to test 0, 0 again. So we're going to test 0, 0 in the bottom inequality, this one right here. And if we do that, we plug in 0 for x, 0 for y, we get 0 is greater than or equal to -5. That is true. So since the point 0, 0 made it true, I'm going to shade the left side of that red line. So that is going to look like this. So something like that. Let me slide over here so I got some more room. So then you guys should see that the double, hold on, I got to admit somebody that got bounced out of here. So you guys should see that the double shaded region is, it's over here. It's the part that's red and blue. So there's no, it's not shaded at all over here. It's only shaded red in between. And again, we're looking for the double shaded part that's both red and blue. All right. And maybe for this one, again, we'll pick a couple sample solutions for this one. So a couple sample solutions for this one would be like, because I think they make you do this in the homework. Let's find a couple points in that double shaded region. So maybe we'll pick one like, I don't know, right here. What is that? 1, 2, 3, 4, 5, 6, 7. So that would be like -7, 0. And let's pick another one. Maybe like right here. That would be, I think that's -4, 7. That would also be a solution. So that one is -4, 7. So what would happen is if you picked either one of these points, if you pick that point, if you plug it into both of these original inequalities, it should make them both true. If you pick the point -4, 7, You plug in -4 for x and 7 for y into both of these original inequalities, it should make both of them true. And like I said, I wish I would have stopped more for you guys today and called on you, but I knew that this was going to take a while to draw all those. So maybe tomorrow, I'm going to skip the story problem at the bottom of the page there because we're getting pretty close to the end of the hour. I'll pick that up tomorrow, and maybe we'll just do some review tomorrow then, okay? So we'll do the story problem tomorrow and some review. And then on Monday, we'll probably start chapter 7. We'll do 7-1. And then on Tuesday, you guys will probably do the chapter 6 test. And then on Wednesday, you have no school. Let me stop my recording right now.